In this video, we're going to go through the motions of taking a data set, entering it into our calculator, deciding what type of model best works with it, and then producing that model using technology. So let's start with this example. It says the following data gives the heights and weights of 17 male students. And wants us to find a linear model or regression line for this data. Okay, so we kind of jumped the gun here by saying line, but we'll get this look at this data first off and then kind of agree with what they've already stated here, that it really ought to be a line that fits to this data. But before we do that, we need to make sure we understand which of the variables should be our independent and dependent variables. So remember, the independent variable is always going to be the x, right? And the dependent is always going to be the y. Okay, so when we think about this, you should think about, okay, does it make sense to say that height depends on weight, or does it make sense to say weight might depend on height? And clearly, saying weight might depend on height makes more sense, right? Because if you get an inch taller, you necessarily have an inch more of some amount of body mass, right? So your weight kind of has to increase in that sense. So we would say that y is going to be our weight. And then the independent variable we'll regard as the height. All right, so when we've got our set of data, we're going to put this in our calculator, remember, by hitting the Stat button and then selecting Edit. And then if you've got anything old in your calculator, just go ahead and highlight the name of the list and hit Clear and then Enter. And then again, highlight the name of the list, hit Clear and Enter. Try to avoid hitting Delete. That'll actually remove the entire column, and you'd probably rather not do that. So it's good practice usually to put the X's in list 1 and the Y's in list 2 just to kind of keep it all straight. So I'm going to put my heights in list 1. And magically now it's all complete, just because you don't need to see me entering all of them in individually. All right, so what do we do now? Okay, so as we said, we're always going to store the independent variable, or the x, in L1 and the dependent, or y, in L2. We went ahead and entered it using the stat edit, as we said, so this is just bolded list to remind you of everything. All right, but now we're going to take a look at the data. So we're going to make sure that plot 1 is turned on, and we're going to hit second stat plot in order to take a look. So stat plot is the second function of the y equals button. So I'm going to hit second stat plot. And right now all my plots are off. So I'm going to press enter on plot 1. And there's got a toggle here for off and on. So select on and press enter. Make sure the type of graph that you have is the scatter plot type, which is the first one there. And then just make sure that your X list is list 1 and your Y list is list 2. So if it wasn't, like, just for example, like let's say it was blank or you had something else in there, then the way you do that is do the second function of the number 1 to get list 1. So I'd go second list 1, and you can see down here all these different lists are just the second functions of their respective number. So make sure it looks like that. And then in this bullet here it says zoom stat will automatically adjust the y values to show the data. So if you go to the zoom button and go down to zoom stat, number 9, then it'll automatically zoom in on the right spot of the graph for you. All right, so so this data here, it's kind of scattered there. It seems like a line would be reasonable to put to that data. I don't see any kind of curving happening. So when they told us to make a linear model for it, I think that was wise. All right. So how do we do that? If we want to fit a line to the data, what we're going to do is we're going to say stat and then calc and then lin reg. Okay. So we go to stat just like when we were entering the data in, but then we're going to toggle over to calc, and then we're going to click on lin reg ax plus b. All right, and again, we're going to make sure the X list and the Y list are our list 1 and our list 2, as they're supposed to be. your frequency list should be blank. Mine right now is not, so I am going to hit clear to make sure that that goes away. And then what we're going to do is we're going to store our equation. Okay. Now I realize not everybody has the calculator screen in front of you that I do. So some of you, when you select linreg, it just takes you back to your home screen and it just says linreg ax plus b. Okay. So if that's you, what you're going to do is before pressing enter, you are going to do the same set of commands I'm about to show in store equation. Okay, so what I'm going to do on my calculator screen is I am going to type y1 into that spot. So for those of you who don't have that screen, you're just going to type y1 right after linreg ax plus b. And to do that, you follow that sequence of commands there. And then after you get y1 in here, that's when you're going to go ahead and press enter. All right, so what I do to get there is I click on this vars button. So vars, and then you toggle over to yvars, and then you select the function button, and then you can select y1. And then once you're done with that, if you have a screen like mine, you hit calculate, and if you have a screen like this down here, then you just hit enter. But either way, we should both be seeing the same thing here. We should be seeing y equals 8.72x minus 438. I guess we'll just say 0.0. Okay, so there's our equation, right? So if I put a height in for x, this is a height, right? Then it's going to tell me the weight that goes along with it. And now if I go back to the graph, I hit graph again, it has the line going through it. And so by typing y1 in after linreg ax plus b, basically that stores the equation we come up with in y1 so that it'll show up on the graph for us. Okay, so there's our line passing through our data set. Okay, now on the next page here, it asks us, what is the correlation coefficient for the data, and what does this tell us about the association between the two variables? Okay, so we'll talk about how to find it in the calculator in just a moment, but just some basic principles first of all. The correlation coefficient is the number r, and it ranges from -1 all the way to 1, and then there's everything in between. So -1, we'll say like -0.8, right? -0.30, right? 0.7 all the way up to 1. Okay, so it goes all the way from -1 up to 1. Okay, so what happens is an R value of 0 means there is no apparent relationship or no apparent association between the values at all. So this picture right here is what it would look like if the correlation coefficient was 0. Okay, this one right here, this one might be like R is 0.75. It's positive because there's definitely a positive slope, but it's not a super strong correlation, right? The data isn't too tightly compact together. Whereas this one right here might be something closer to like R equals 0.9, right? So it's positive because there's a positive slope, but the data is a lot more tight. In other words, I'd feel more comfortable making predictions about my Y based on my X. All right, and then this one here, it's definitely got a negative slope, right? So, I don't know, we'll call this R equals -0.65, just to throw a different number out there. And then this might be like R is -0.8, 0.88. Okay, so getting closer to -1. So the closer you are to 1 or -1, the stronger the relationship is. Negative meaning it's a negative relationship, and positive meaning it's a positive relationship. Okay. So it's nice to know what is the correlation coefficient, right? How strong is the relationship that we're seeing? Okay. And so in order to find it, what you do is you make sure that you have your diagnostics turned on your calculator. So what I do is I hit second catalog, and catalog is the second function of 0. And you've got this big long list here, and I'm going to scroll down until I get to the D's. And I'm going to select diagnostic on, and I'm going to press enter. Now what that just did is seemingly nothing, but what it does is now every time that you produce your equation, it's also going to tell you what the R value is. So if I go back and do the same steps to get my equation, so I go to Calc, Linear Regression, L1, L2, and I store my equation in Y1, and I hit calculate. Now it just doesn't just give me the equation, it also gives me this thing called R squared and then the R. The R squared is important in data analysis, but we're not going to worry about it. The R value is the one we're talking about here. So what we can say is for our little problem that we're doing, R is 0.646, we'll say. And if I click on the graph again and kind of look at how this is spaced out, you know, kind of similar to how this is spaced out, so you can kind of see the relationship here between the number I kind of made up and what we're seeing in our data set. So what we would say about this is that there is a positive, because there's a definite positive slope, but I would say it's not a super strong relationship in that the data isn't too tightly held together. So there's a positive, we'll call it moderate relationship between height and weight. And I think that that kind of goes with our experiences, right? You know, of course, you know, people who are taller are going to weigh a little bit more, right? Height has a lot to do with it, but there's a lot of other factors that affect our weight as well, like, you know, what kind of exercise we do and that sort of thing. So so it kind of makes sense that, yeah, height is a pretty decent predictor of weight, but it's not perfect. All right, so now what we're going to do is we're going to talk about the equation we came up with and apply it to some problems here. So let's go back for a moment and just remind ourselves, we can do this in the calculator, right, of what our equation was, right? It was y is equal to 8.72x minus 438. So first of all, what is the meaning of the slope? Well, this is something that we've done in this class, right? We know that the slope is the number we're multiplying x by, and I think it helps, remember, to say that 8.72, we can force it to be a fraction. And the reason it's helpful to force it to be a fraction is because we can then remember that, okay, the 8.72 is the change in y, right? And the 1 is the change in x. Right? But of course, what is y and what is x? Y is the weight and x is the height. So what I can literally say is that for each additional inch in height, right? That's the change in x part. We expect about an 8.72 pound increase in weight. All right. And then part D says, what does the model predict the weight of a 70-inch tall male student is? Now, we've done this manually many times, so I want to show you kind of a slick way you can do this in your calculator. Is we have this equation, right, that we know that if we plug a particular height into it, then it'll spit out the y value, the weight. So what you can do is say that your weight here, or your y value, is going to be taking the equation y1 and putting 70 into it. So in your calculator, you can just go back to your home screen and then pull up y1, go ahead and do the vars, yvars function y1. So you can get that on your home screen. And then in parentheses, just put 70. And that'll be telling you to or telling your calculator, go get the equation, put 70 in for x, and tell me what the y value is. And what we get here is a y value of about 172.6 pounds, right? And then part E says if a male student weighs 155 pounds, how tall would we expect him to be? Okay, so now they're telling me that y is 155, right? So what is x? So to do this, what we can do is use our graph. So if you go to your y equals menu, and in y2, go ahead and put 155 as the y value. And then if I go to the graph, you'll see the original equation and 155. So if you just ask the calculator, where do these two lines intersect, then that'll tell you what the x value should be. So you just go to second calc, intersect, and then it just asks for the first curves. Okay, so hit enter for the first curve, then it goes down to the red one. Is this your second curve? Yes, so I hit enter, and then I'm just going to get near the intersection point and press enter, and there we go. X is about 68, right? X is about 68 inches. Now, in both of these cases, if you want to just do this manually, right, in this case, you would have just said y equals 8.72 times 70 minus 438, and then would have gotten basically pretty close to that answer. Or if you would have gone 155 as the y is equal to 8.72x minus 438, and solve for x, of course, that'll get you the same answer. So I don't care if you do it that way, but I just wanted to take this chance to kind of show you how you could use your calculator to get that same information.